Without any further delay, I would like to introduce our next speaker, and that would be speaking to soil health concepts and practices, Dr. Melanie Willich. Did I get that right? Thank you for joining us.
Okay, test. Please bear with me while I'm getting used to this atmosphere. I write a lot of grants on the computer. I live in Pauilo in the forest. I do drive a tractor every day, but this is a little different than sitting on Zoom. Is that okay? Oh, that's okay. Yeah, thank you for inviting me today. My name is Melanie, and I work with the Kohala Center. It looks like I brought the wrong slides, but that's not the case. I would just like to introduce a little bit. Oh, not sure what is happening here. Could you just put this in the presentation mode? That one, yeah. Thank you. Yeah, I don't know how familiar you are with the Kohala Center. It is a local nonprofit organization based in Waimea. We work with an array of partners across several ecosystems, ranging from Kahaluu Bay, not far from here, all the way to the Kohala cloud forests. So we have a lot of staff working in different ecosystems where for each one we have an overarching research question that guides our programs. In our agricultural work, we serve about 250 producers across the state each year. And our question is, how do community-based food systems nurture the health of our working lands and people across the island and the islands? We do that as part of our rural and cooperative business development services that provides support and co-op development, business planning, capitalization. We do have 2 microloan programs. We also provide farmer training. We collaborate with the Hawaii Seed Growers Network that evolved from our public seed initiative. And I have a cooperative agreement with the NRCS Waimea Field Office looking at forage yield studies and two-line spittlebug resistant forages for our rangelands. So you see, it is very complex, and as complex as our agricultural systems are, as complex are the answers to this research question. Today, in this topic of soil health, we want to approach that question through the lens of how does soil health affect coffee production, and in turn, how does the way we produce coffee affect soil? So soil health is an evolving concept that is much broader than maybe what you're familiar with as soil fertility when you do soil tests to find out what is the nutrient content, so what is the ability of a soil to provide nutrients to a plant. That literally is the definition of soil fertility, which was the major driver of soil management in the last century. It is part of soil health, but soil health is a much broader concept in that it also looks at the roles that soil play in the water cycle, the ability of a soil to infiltrate, to let water infiltrate, to also regulate it, the way it flows in the soil profile and makes it available to plants or not. Also, a healthy soil has the ability to act as a sponge and filter water, but also chemical pollutants. So all these are aspects of soil health that can just as well be degraded and not fulfill these functions very well. Soil is central for cycling nutrients to make them available to plants, which we need for our yields and quality of crops. Soils also provide the physical support for roots as well as the habitat for all plant, animal and microbial diversity. So these things can be measured. As I said, you might be most familiar with soil fertility and an analysis of soil nutrient contents. But if you think about what soil is, you have soil physics, anything that has to do with structure, the arrangement of the mineral parts, anything soil hydrology related, the water flow in soil. You also have chemistry around the weathering of the minerals, around the decomposition of organic materials, and you also have soil biology. Yeah, all these microbial communities that drive the chemical processes of nutrient transformations. So as you can see, each of these properties, the physical, the chemical, and the biological, have their own measures. What guides or affects all of these soil properties is soil organic matter. That is really the key vital component of soil health. Soil organic matter is chemically very complex and cannot directly be measured. So what you will see in the later slides is basically carbon in which soil organic matter is measured, because about 58% of soil organic matter is carbon, which is an easy direct measure. In our soils here, mostly the total carbon sort of equals organic carbon, because we're not limestone based and have mineral carbon in our soils, but because we're all basalt based, the total carbon pretty much is what the carbon in organic materials represents. The sources for organic matter are any crop residues that you're incorporating, any cover crops, roots. It's the living microorganisms just as well as the dead ones, and organic materials in all stages of decomposition. All of that makes up organic matter. And if we have only little of it, we're talking about a degraded soil that is not able to fulfill all these functions that we mentioned. On the opposite, the more organic matter we have a reservoir for soil nutrients. so our soil chemistry improves with that. We also have habitat and food for the microorganisms. So all these microbially driven processes can function better. And soil organic matter supports the physical properties, structure, things like soil tilth, which we need for good root penetration. Also, it helps to decrease the risk of compaction because it increases aeration and also things like water infiltration, but also water holding capacity. And as climates are changing, that becomes more and more important. Also, it reduces the risk of erosion or runoff as soil structure is improved. So how do you do that? There are 4 principles on how you improve soil organic matter contents, and with that soil health and function. Minimizing soil disturbance, that would refer to minimize tillage, so to not disturb these structural improvements, but also to basically decrease the aeration that tillage would cause, which basically makes microbial activity, gives that a boost, which then leads to decline in soil organic matter contents. Of course, these things are also compromises and can, only go as far as is practical. Sometimes with weed competition, there's no way around tillage. But in general, tillage should be minimized in order to keep organic matter contents good. Also, the diversification of soil microbial communities helps them fulfilling all their various functions, and that can be achieved with plant diversity. So you go into these mixed type cropping systems, complex agroforestry systems, things like that. Provide continuous living roots, maximize soil cover with basically additions of organic materials or growing cover crops, practices like that. Now, what we did with the KU United Farmers Cooperative as a specialty crop block grant program over the last over a year, 2 years, we planted cover crops in participating farms in KU and chose those cover crops based on what we wanted to use legumes, so nitrogen fixers, to see if over time some of the nitrogen fertilization could be reduced. And we were also looking for good weed suppression. So we ended up choosing stylo, cowpea, and perennial peanut. We came to the red clover a little later that I will tell you about in a slide. And each farmer planted several rows of each of these cover crops against a control. We used these seeding rates based on what we could find in the literature. And you can see in terms of plant architecture, the stylo is an erect plant with very small leaves that is a good biomass producer. The cowpea, you see that photo during its establishment. It's a quite whiny plant, and the perennial peanut and the red clover are similar in their architecture, The red clover is a little skinnier in its stem, but has similar leaf shape. And the perennial peanut really, it looks like a carpet, like a green carpet. It's a very hardy plant, very strong, low to the ground. So it has good properties to be used in an orchard system. Now, a few of these findings. Here you see a graph of the baseline total carbon, which, as I said, represents soil carbon pretty much one-to-one, and the total nitrogen. What you can see is that we're pretty good in KU in terms of inherent soil carbon contents, around there like 5 to 6.5%. We have a general range of somewhere between 2 to 10%, depending on the ecosystem and its management. What is considered quite optimal is between 3 to 5%, so it's looking pretty good, except for one farm where we had a soil carbon content of less than 1%. So there you can imagine pretty much a bare mineral soil that has not received organic inputs, less than 1%. As we've mentioned previously, this soil will not have good water infiltration capacity. It also cannot provide nutrients because the reservoir of the organic matter is just very, very small. And you see how beautifully this is linked to the soil nitrogen contents. In that farm, the nitrogen that can be made available to the plants is very low as well. So now we basically followed the course of this project for a little over a year with soil sampling. And you see in the left graph that farm that started off with that very low soil carbon content. And the reason I don't show you here the control is because the control ended up not being a real control, but it also had a lot of cover of, broadcasted seed that made its way in there, but also wheat biomass. So in fact, our controls had very similar results to the cover crop rows because they were not real controls. That's why I didn't put even more data in here to make it more confusing. But for an easier overview, you see that the soil carbon content over time more than doubled in that farm, and that all the crops were good root mass producers. That's basically where this increase comes from. And over a relatively short period of time, in a soil parameter that is not very quickly responding, we had very good results. You see in the stylo, this drop there after November was due to the fact that the stylo died back and the microbes just turned over those materials, and this would have to be replanted, which is another management consideration. The farmers' feedback was that they're most excited about the perennial peanut and the red clover, which can easily handle mowing and even thickens with regrowth after a mowing event. And you can see that in the data as well, that these roots, what happens above ground is mirrored below ground. Next to it, just as a comparison, I put another of the participating farms to show that we started off at a higher carbon content and still could increase for across those cover crops about 20% from like an initial 5.7 to 6.89-ish. What looks a little drastic in this graph is that drop toward November in the perennial peanut, but really that is just 1% and just reflects how these processes are dynamic and also climate dependent. Yeah, like over the summer months there's a lot of growth, but there's also heavy microbial activity, as is just the case more in our subtropical climates, and that's why we need to continuously input organic matter to keep those contents up. Otherwise, the microbes will respire carbon faster into the atmosphere than we can build. So also normal process. In summary, the germination and establishment was very good in the red clover. Those seeds had a high germination rate compared to the seeds of the perennial peanut that in the course of this project actually has been stopped to get imported to the state. Perennial peanut has been a more expensive seed and now is not available anymore. But as this was one of these obstacles that came up unexpectedly, we had the opportunity to also test sprigging and vegetative propagation, that we had very good results with establishment and filling. Of course, especially with rust and other diseases, this would have to be looked at much closer as to not spread disease by using vegetative propagation. But you see in those top two pictures how to the left that perennial peanut was propagated by sprigs and made pretty much weed-free green carpet, great cover, low growing, easy to manage, very good, can handle traffic and everything, can handle some harder climates as well, can get through drought, things like that, if not mow too low. And the right top picture shows actually that difference to when we planted with seed, where the establishment just took longer and weeds had, greater opportunities to compete. Once established, however, the perennial peanut is very good in weed suppression. The red clover was nearly as good. The plant stem grows a little higher, so the weeds have some more chances to come in between. But since it can handle mowing, it also thickens over time. It was just found to be very good seed quality, cheaper seed. We would just next time now recommend a higher seeding rate than what we found in the literature, and instead of these 30 or 40 pounds per acre, actually be closer to like 80 to 100 pounds per acre to make sure we get them quick established. And the lower photos just show on one of the farms there was also mulch spread, and that boosted the establishment of the cover crop even better. And same would be when we planted in spring or summer, when the days are longer, it's warmer compared to how we did that in the study and started at the end of December. So these are also factors how you can get ahead with it. The stylo, although it was such a great biomass producer, compared to the perennial peanut and the red clover, was not so preferred because it's growing higher. It also lets weeds through, and it would have to be resown. We did a lot of soil tests as well, so I wanted to point out some things about nutrient management, as I see that as a low-hanging fruit, since cover crops is not an option for everyone for a variety of reasons. And you see here how we started off with the pH baseline across those farms. I put as this orange marker sort of what is considered optimal for coffee that likes it a little more acid, around pH 5.8. We have in 3 of the 5 farms a pH that is above that. The first 2 farms are acceptable. The third one is really quite high. In farms 4 and 5, it's below what is considered optimal. Farm 4, I wouldn't be concerned. Farm 5 at a pH 5.5 is really at a critical point where it should not drop further. I want to compare that because we are in Kona. There are, I assume, are a lot of Kona growers here as well. And I sampled a few soils here about 2 years ago, and it's similar that we have, you know, here farm 1, that's okay, farm 3 is okay, farm 5 is okay, but we also have extremes. Farm 2 is at a pH of 4.5. That's quite acid. And then we also have a farm that's at 6.7 that is very high. So why is that a problem? Why does that matter? Because pH is regulating a lot of the soil chemistry. So generally, briefly speaking, if there is a small window of pH in which our essential nutrients are available. And if we go below 5.5, we run into problems of phosphorus being tied up, and also our major nutrients getting into deficiency issues, mostly because they are leached out at that point, or not available. And the same is when you go up the opposite end of the range. If we're going into a too high pH, then we again have phosphorus deficiency, because phosphorus is the most reactive element in the soil. So in a low pH, it reacts with aluminum that starts to get dissolved, actually leading to toxicity. Yeah, in this one farm that has 4.5, for sure there is aluminum dissolved that is causing then root damage, and then your coffee trees will not be able to explore enough of a bulk soil volume, which then leads to indirect deficiency of other nutrients. And in particular, this will be phosphorus, which is one of the major yield-building nutrients. And in higher pHs, we also have micronutrient deficiencies. The yield the micronutrients, although they are only required in very small amounts, They are all essential. And the yield is governed by the least available nutrient. So it does not matter if you apply more and more and more of the major nutrients when one of the micronutrients is lacking, yeah, which will limit the yield of your coffee and also the quality. So what we see here in this graph on the left two axes is the soil phosphorus and potassium, and on the right axis is the calcium and magnesium content. And so how does this look like in our KU farms? Phosphorus should be at least at 50 ppm, which is same like a microgram per gram or milligram per kilogram. So let's just keep it short, call it 50, you know what unit I'm talking about, any of the three above. And you see it is low. In 4 out of the 5 farms in this light gray bar column, yeah. But is it even available in the farm 5? Because we remember there was also some issue around pH. The potassium, that should be at least at 200, and you see it's also all across the board. So I just want to show this to give you an impression there. Soil calcium, that should be at least at 1500, and it is shown here in this in the blue dots, and you see very clearly it's okay, but in farm 3 it is extremely too high. So that makes sense because farm 3 also had this very high pH. So what happened here most likely is that they just limed, not according to a lime requirement curve, but just in tremendous amounts, which also is costing you money that is not doing anything. In fact, it pushed your pH to a point where the nutrients are not even available. Yeah. As you can see in the phosphorus, it is already low, but the phosphorus that's there is most likely not even available. Yeah, similar with potassium. And if we jump here a little back and forth, you see this is completely reflected, okay, enough, in the leaf tissue. Yeah, it's a mirror. What happens in the soil, that's what's going to happen in your plant. So we have the tissue phosphorus should be at least at 0.1%. Yeah, so it's low everywhere. It's a yield building nutrient. Yeah, so there is potential being given up because of nutrient management, room for improvement. The potassium should be at least at 2%, so we have that given in 1 out of the 5 farms. And the calcium and magnesium, that looks pretty good, and that is what we saw in the soil as well. And also to not forget Kona again, those same samples that I showed with the pH, where we had, remember, some extremes in farm 2 with very low pH, and farm 4 with this very high pH. Again, we see that reflected. Yeah, calcium and magnesium, that's what is in your liming agent, calcium carbonate or magnesium carbonate. And you see in farm 2 that had a pH of 4.5, there has been no liming application. Maybe also low soil organic matter. Yeah, but we didn't measure carbon there, but soil organic matter buffers changes in pH. That's one great advantage. But here, clearly, I would imagine if we looked at that coffee, I would not expect healthy looking plants. In farm 4, you see a total extreme calcium here, over 5,000 ppm. That should be around 1,500, definitely not above 3,000, but is much more than that. So that costs someone a lot of money with no positive effect. Magnesium, that also is above 500 in all of those farms except for the farm 2 that could actually use some of what was applied in farm 4. Phosphorus is over-fertilized in all of the 5 sampled farms, like in huge factors by 10, yeah. And that's an issue, because where does all this phosphorus end up? In a rainfall that straight up washes away into the reefs, causing environmental problems. Potassium, also all over the place, and especially that farm 4 has applied just, not based on a previous soil test, is what I would assume. And that is a low-hanging fruit, which I want to point out Andrea's publication. Taking regular soil tests and leaf tissue tests to base your fertilization practice on that will help your soil, will also help your coffee, especially as you're so challenged by the leaf rust and other diseases. Setting the crop up with a good nutrition is its first line of defense. And I think that is something that is maybe more applicable than cover crops if that is not an option for you. But these were the 2 main points I would like to bring across here today. And I want to thank the KU United Farmers Cooperative, especially Joan and Lori and John Arsan, and all the participating farmers in KU and Kona. Stay in touch. As I mentioned, Kohala Center is assisting producers with soil and tissue testing through our grants, as well as helping with the interpretation and actually making fertilizer recommendations. I want to thank the HDOA Specialty Crop Block Grant Program. And we also have cover crop seed to give out at Reggie's booth. And if you have questions, please ask them now. I don't know how we are with time, or I will also be around afterwards. Thanks a lot for coming. Yeah, that's a good point. That is something that came up for us also during the study. As I said, okay, going home. I don't want to take it, I think Melissa is looking at this still, right?
Like you were talking about phosphate and washing of the reefs, I kind of have to think, it seems like if we're fertigating, bringing temperate ore through the water, stressing the soil, puts a fair amount of potassium, that's going to be very immobile in the soil. Incorporating with the water, how is that a problem?
That depends, first of all, on the pH of, where is the phosphorus tied to or not. You are correct, phosphorus is extremely immobile. That's why it's causing such problems if the pH is not right, that if the plant root is not just there where the phosphorus is, it's having a hard time picking it up. But the way phosphorus ends up in a reef is by surface runoff. So if there is a lot of phosphorus in the soil, however it is tied or dissolved, when the soil is not held well by roots of cover crops or whatever, what happens is basically sheet flow, and all the phosphorus that is in that topsoil, that's how it ends up then off farm elsewhere. Yeah. Good question. That was not a primary focus. I cannot answer it for stylo on the top of my head now, but none of the others are susceptible. Yeah. Yeah, that's a very good question. I'm not sure if there are studies that is interesting to look in actually, if there could be susceptible cover crops used as trap crops to divert them away from coffee, but then also with these type systems it could increase the overall population that then could be problematic. So maybe more looking into crops that are actually nematode suppressant by fumigation type activities. I would think it might be more promising. Okay, thanks.
Thank you. And thanks to the Kohala Center for making Dr. Willich available. Hopefully you folks can connect with more questions. A few announcements. Please visit the trade show. Please visit the silent auction, ends at 1:30. Our dinner tonight will be at Ray's on the Bay, so please join us. We'll be presenting the HCA's first Lifetime Achievement Award and our Legislator of the Year Award. And we expect remarks from Congressman Kai Kahele. So please join us for that at Ray's at the Bay. Ray's on the Bay at 6 p.m. Our schedule has changed slightly. Our elections will be at 2:45. And we're going to take a short break now. And we appreciate the coffee donated by Tradition Coffee Roasters. So reconvene here in about 10 or 15 minutes. Thank you.